Hi my dear students, this is Suhasini. Today we are going to see exercise 1.4.
Now we'll see exercise 1.4. Determine whether the graph given below represents function. Give reasons for your answer concerning each graph. Okay, so these are the 4 graphs they have given. So you have to say whether this is a function or not. Okay, so this is x-axis and this is y-axis, and these are the curves given in a graphs. Okay, so what you have to do is you should draw a vertical line. If you draw a vertical line, when the vertical line touches or meets the graph at only one point, then it is a function. Okay, the vertical line should pass through the graph or meet the graph at only one point, then it is a function. If it is more than 1 point, 2 point, like 3 points, so then it will be what? It's not an function. Okay, so now we'll check whether this is a function or what. So first what you have to do, so you have to draw a vertical line. See, I am drawing a vertical line here. Okay, so here you can see the line, vertical line meets the graph at 2 point. At 2 point the vertical line is meeting the graph. So then this is not an function. I said it should meet at only 1 point. Okay, so this is not a function. So how will you write the answer? The vertical line meets the curve at 2 points. Therefore, it is not a function. Okay, therefore it is not a function. Got it? So now we'll check with this. Okay, so you can draw a vertical line at this place or this place also. Okay, just see there, the vertical line meets the curve at only 1 point. So in this vertical line meets at this point, and this vertical line meets at this point. So it is meeting at only 1 point. So therefore it is a function. So what reason you will write? The vertical line meets the function, meets the curve at 1 point. Therefore, it is a function. Got? So now we'll check with this graph. See, if I draw a vertical line like this, see, the line is meeting at the 2 points on the curve. And if I draw a vertical line here, here also it's meet at 2 point. So if it is 2 point, it is not a function. So directly you write here, the vertical line meets the curve at 2 point, therefore it is not a function. Got it? So now we'll check with this. So if I draw a vertical line here, it's meeting at only 1 point, and if you draw a vertical line here, it's meeting at 1 point. You can show any one line, it's more than enough. Okay, so if you show this line, it's more than enough. So it's meeting at only 1 point, so therefore it is a function. You just write the vertical line meets the curve at only 1 point, therefore it is a function. So it is a function. Okay, so now we'll see second question. Let a function f from a to b be a function defined by f of x is equals to x by 2 minus 1. Okay, so this is the function they have given. Whether a is 2, 4, 6, 10 and 12, b is 0, 1, 2, 4, 5 and 9. Represent f, that is function, by first set of ordered pairs, next a table form, next arrow diagram, next an graph. Okay, so you have to show. So first we'll start off with set of ordered pairs. So before that, what you have to do, so what they have given, function they have given, function is what? A function a from b. So f of x is what? x divided by 2 minus 1. So what you have to do, take a value. So what are the a values they have given? 2, 4, 6, 10 and 12. And what are the b value they have given? 0, 1, 2, 4, 5 and 9. Okay, so what you have to do first? So take your f of x, substitute the a values in it. Means in the place of x, first you substitute 2, take the value, next you substitute 4, take the value, next 6, like that. Okay, so first we'll do f of 2. So f of 2 in the sense wherever you have x, substitute 2. So 2 by 2 minus 1. So 2 by 2 is 1. So 1 minus 1 is what? It's 0. Okay, next f of 4, which is 4 by 2 minus 1, which is 2 minus 1. So 2 minus 1 is what? It's 1. Next, f of 6. So 6 divided by 2 minus 1. So 6 by 2 is what? 3. So 3 minus 1 is what? 2. Next, f of 10. So 10 divided by 2 minus 1. So 10 by 2 is what? 5. 5 minus 1 is 4. Next, f of 12. So that is 12 divided by 2 minus 1, which is 6 minus 1. It is 5. Okay, so you got all the values. So now what you have to do? So you have to show this in set of ordered pairs, a table format, and in an arrow diagram and in a graph. Okay, so first we'll do set of ordered pairs. So set of ordered pairs, what you have to do? So set of ordered pairs is you have to write the function in ordered pairs. That's it. So when it is 2, the value of f of 2 is 0. When it is 4, it's 1. When it is 6, it is 2. 10, 4, 12, 5. Got? So this is how you'll show in an set of ordered pair. Next, you have to show in a table format. So to represent in a table format, you take x and f of x. Okay, so x and f of x. So 2, 4, 6, 10, 12. Okay, so you just make an table format. Okay, so when it is 2, it is 0. When it is 4, it's 1. When it is 6, f of x is 2. When it is 10, f of x is 4. When it is 12, f of x is 5. So this is how you'll represent in table format. Okay, so now they have asked to draw an arrow diagram. Okay, so now we'll see arrow diagram. See, I have shown an arrow diagram here. So let this be an A and this is your B. Okay, so you have to map the arrows here. So now when it is 2, your f of x is what? 0. When x is 4, so your f of x is 1. When x is 6, your f of x is 2. When x is 10, your f of x is 4. When x is 12, your f of x is 5. Got? So this is how you represent in an arrow diagram. Got it? So now next they have asked to show in a graph format. So I have already shown here. Okay, so this is how you will draw your x-axis and y-axis. See, for x-axis the reading have taken as 2, 4, 6, 8, 10, 12. Why? Because see here in this A or X you have these only. Okay, so therefore I have taken these as 2, 4, 6. If I take 1, 2, 3, 4, 5, 6 like that, it takes very lengthy. Okay, so 2 units have taken. In y-axis 1 unit only I have taken. Okay, so 1, 2, 3 only I have taken. So that's what I have written here. X-axis for 1 centimeter I have taken 2 unit. For 1 centimeter I have taken 2 unit. In y-axis for 1 centimeter I have taken only 1 unit. Got it? So that's what I have written here. So if you show this in exam, it's good. Okay. So now let's map now. Let's draw a graph now. So when it is 2, so when x is 2, so what is your f of x? So your f of x is 0. So when it is 2, your f of x is 0. When x is 2, your f of x is 0. So this is the point. So right there 2, 0. Okay. So then when x is 4, your f of x is 1. So this somewhere here. So this is your 1 and this is your 4, right? So 4, 1. Then when x is 6, your f of x is 2. So somewhere here. This point. Okay. So 6, 2. Then when your x is 10, then your f of x is 4. So here your 4 is, so this is the 10, right? Somewhere here it will meet. So 10, 4. Next, when your x is 12, your f of x is 5. So here your 5 is, so 12 is here, somewhere here it will meet. Okay. So 12, 5. Okay. So your graph will look like this. Okay. So this is how you'll represent in graph. Got it? So now we'll see next sum. So third sum. Represent the function f is equals to 1, 2, 2, 2, 3, 2, 4, 3, 5, 4 through an arrow diagram, a table form and a graph. So you have to represent this function in arrow diagram, table format and graph. Okay. So first we'll show arrow diagram. So in arrow diagram, so these are your x values and this is your f of x values. Okay, b values. So here have shown the arrow diagram. So when your x is, a is 1, your f of x b is 2. Okay, so let's start mapping now. When it is 1, b is 2. So when it is 2, b is 2. When x is 3, f of x is 2. When a is 4, b is 3. When a is 5, b is 4. Okay, but instead of showing like this, so what you have to do, so draw a arrow diagram like this. So 1, 2, 3, 4 and 5. See, for all 1, 2 and 3, the value in the b is 2. Okay, so 2, 3 and 4. Got it? So here how will you map? For 1 it is 2, for 2 it is 2, for 3 it is 2, then for 4 it is 3, then for 5 it is 4. So like this you can show your arrow diagram. Got it? So instead of doing this, do this. Got it? So this is how you'll be drawing your arrow diagram. So now we'll see table format. So how will you represent your table? Okay. So when your x is 1, so your f of x is what? 2. When your x is 2, what's your f of x? 2. When your x is 3, what's your f of x? 2. When your x is 4, what is your f of x? 3. When your x is 5, what is your f of x? 4. So this is how you'll represent in a table form. Got it? So now we'll see the graph representation. How will you represent in a graph? So in graph, so first you have to draw your x-axis and y-axis. Okay. So in x-axis I have taken 1, 2, 3, 4, 5. In y also I have taken this. Why? Because see here you have a continuous 1, 2, 3, 4 in x-axis. Here 2, 3, 4. Okay. So there is no any 2 points difference or 3 points difference. So what you do? Directly you take 1 unit 1 centimeter. So you represent here x-axis for 1 unit 1 centimeter. For y-axis 1 unit 1 centimeter. Got it? So that you have to mention here. If you mention, it's fine and good. Okay. So now, we'll start drawing. So when x is 1, your f of x is 2. So when x is 1, your f of x is what? 2. So it is what? 1 comma 2. So now next, when your x is 2, your f of x is 2. When x is 2, your f of x is 2. 2 comma 2. Okay. So now when your x is 3, your f of x is 2. When x is 3, your f of x is 2. Which is 3 comma 2. Okay. Next, when x is 4, your f of x is 3. So 4 and 3 somewhere here. That is 4 comma 3. Next, when your x is 5, your f of x is 4. So 5, 4 is here, somewhere here. So it is 5 comma 4. So if you want, you can leave this like this only, or you just show like this. Got it? So this is how you'll represent in graph. Okay. So now we'll see next sum. So now we'll see fourth sum. Show that the function f, that is natural numbers both, defined by f of x 2x minus 1 is 1 1 but not onto. So any natural numbers, so you have with this function is 1 1 but not onto, you have to show. Okay, so for this what we'll do, so you just take any natural number. Let's 1 2 3 is a natural number, right? So substitute that value in x place and take your f of x value. Okay, see, suppose your first we'll take 1 2 3. So first in the place of x you just substitute 1 and take the value. So 2 into 1 minus 1, that is 2 minus 1 is what? 1. Next, f of 2. So 2 into 2 minus 1, which is 4 minus 1 is what? 3. Next, f of 3 minus, that is 2 into 3 minus 1. So 6 minus 1 is what? 5. Next, f of 4. So 2 into 4 minus 1, which is 8 minus 1 is 7. So like that it goes on. So I have taken all natural numbers. Okay. So now what we'll do, you just draw an arrow diagram. So this be your A and this be your B. So this is your A and this is your B. Okay. So we are doing f of x, right? So here this is natural number 1, 2, 3, 4 and so on. Okay. It's going on. They have given n. So it's going on. So now B. So B 1, 2, 3, 4 and 5, 6, 7 and it's going on. Okay. So now what you have to do, you have to map now. So for 1, your value, f of x value is 1. Okay. So for 2, it is 3. For 3, it is 5. For 4, it is 7. Okay. So now, what you do, just see, it is a 1 1 function, which means for all the element in A as its own image, own unique image in codomain. Yes. So it says is unique images. So it's all elements are mapping. So this is what? It's 1 1 function. Okay. So by this you can say f of x is 1 1. But you just see there is a leftover terms in B. There is no any pre-images for some elements. So there is no any pre-images for some elements. So if there is pre-images for every element, then it is what? It's a onto function. But there is no any pre-images for some elements in codomain. So therefore, this is what? It's not an onto function. Got it? So for some elements there is no any pre-images in domain. Okay, for some codomain there is no pre-images in domain, so therefore it is not an onto function. Okay, so how will you represent this? So different value of a or x in domain in the sense elements in the x as different unique image in codomain. So therefore it is what? It's 1 1. 1 1. Okay. So now how will you say it is not onto? The elements in Y or codomain does not have pre-image in domain. It doesn't have any pre-images for some elements, like for even numbers. Okay, so it doesn't have any pre-images. So therefore it is not, it is what? It is not onto. Okay, so on other words you can say even numbers. See, just note here 2, 4, 6 and etc. etc. So for even numbers in codomain does not have pre-image in domain. Therefore it is not onto function. Okay, so you can either write like this or like this, but you have to write a statement like this. Okay, fine. So now we'll see fifth sum. So before going into the fifth sum, I would like to say you this. I'll show you one more method. So whether this is 1 1 or what. Okay, to show that. So what you do, they have given this f of x, right? You take this as f of x1 is equals to f of x2. Okay, so what is your f of x here? Means 2x minus 1. So if it is f of x1, you just substitute x1 in the place of x, which means 2x1 minus 1. If it is x2, you just put 2x2 minus 1. Okay, so what happens? I'll just cancel this minus 1 term on both sides. Next, 2x1 is equals to 2x2. Okay, so then I'll cancel 2 and 2. So it becomes x1 is equals to x2. Okay, so whenever you see this put like this, then it is nothing but it is an f of x function. F of x is an 1 1 function. Okay, so 1 to 1 function if you show like this. So this is, or instead of this, if you want to do like this, you can show like this. So if you want, you can take this as f of x is equals to f of y also. Okay, so if you show x is equals to y, yeah, yes, it is an 1 1. Okay, so this is OR. Fine, now we'll see fifth sum. So now we'll see fifth sum. Show that the function f, that is n to n. So already have said n to n in the sense natural numbers. Okay, so natural numbers defined by f of m is equals to m square plus m plus 3 is an 1 1 function. Whether this f of m is 1 1 function or what, that's what you have to prove. Okay, so for that what we'll do, so natural number in the sense you take 1 2 3 4 and substitute that in the place of m and take your f of m value. Okay, so what we'll do, so f of 1, which means wherever you have m, substitute 1. So 1 square plus 1 plus 3, so which is 1 plus 1 is 2, 2 plus 3 is 5. Okay, so next f of 2, so next natural number you take. So that is f of 2. So 2 square plus 2 plus 3. So 2 square is what? 4. 4 plus 2 is 5, 6. 6 plus 3 is 7, 8, 9. Okay. So 9. Next, f of 3. So 3 square plus 3 plus 3 again. So 3 square is 9. So 9 plus 3 is 10, 11, 12. 12 plus 3 is 15. Okay. Next, f of 4. So 4 square plus 4 plus 3. So 4 square is 16. So 16 plus 4 is 20. 20 plus 3 is 23. And so on. So it's a natural number. Okay. So now what you have to do? You have to draw your arrow diagram. So what you do? Draw an arrow diagram. So this is A and B and both are what? Natural numbers. Natural number in the sense. So 1, 2, 3, 4, 5, etc, etc, etc. Here 1, 2, 3, 4, 5, some space 9, some space 15, some space 23 and so on. It goes on. Okay. So now why I did like this? Because I need these 9, 15, 23. So that have left these spaces. Okay. So now what we'll do? When it is 1, your f of x value is what? 5. So, okay. So when it is 2, it's 9. So where is your 9? Here it is. So when it is 3, it's 15. When it is 4, it's 23. And for 5, 5, 6, it goes on the value. So by seeing this only, you can say for every elements in the domain, means whatever the elements in A as its unique image in B. Yes. So as its unique images in B. So if it is like this, what it is? It is an 1, 1 function. So what you do? Directly write different values of domain. So different values of domain have what? Have unique images. Have unique image in what? Codomain. Therefore it is what? It is 1, 1 function. Got it? But it's not onto. Why it is not onto? See, so there is many leftover numbers. It doesn't have any pre-images in domain. So there is no any pre-images in the domain for codomains. Okay, so this, it's not an onto function, but they didn't ask you. They just asked you to show whether it is 1, 1 or what. Okay, so yes, it is 1, 1. So all the elements in the A has its unique images in the B. So therefore it is what? It's 1, 1. Okay, fine. Thank you. Thank you so much.